Hey everybody, we're going to try to do a daily board repair video again. So this here is an A1502 Retina MacBook Pro that has no power. We're going to try to figure out why it has no power. So let's open it up, dig into this machine, and see if we can make it work again. And as you can see here, it's taking 79 milliamps, and also we don't get a green light. So one thing you should know from my last video is that the no green light could be a number of things. It could be PP3V4 too shorted to ground. It could be PP3V4 too missing. It could be that the power button is stuck. So because if the power button is stuck pressed down, it's going to think it's trying to do an SMC reset. So I just unplugged the keyboard because the keyboard is going to be responsible for the power button. As you can see, we have no change here. So I'm going to take the board out of the case, and we're going to see what happens there. So let's get the board out of this case and go from there. But while we're taking the board out of the case, just don't remember that we should definitely send in the clowns. Where are the clowns? Please send in the clowns. And we're going to plug this in again. Now that everything has been unplugged, we're going to see if that makes any difference. Doesn't seem to make a damn bit of difference. So we're going to open up a schematic for the 820-4924 in Paul Daniels' lovely software, available at pldaniels.com. That's pldaniels.com. There's an open source version that you can try that does not include the thing where you'll automatically find signals in the PDF that you right-click on in the board view and vice versa, but it's still really good stuff, and you should check out his site because he's contributed a bunch of lovely stuff to our industry, like the multimeter software that allows you to see the voltage on screen right over there. It's good stuff. Picked at random. Indeed, picked at random. First thing we're going to do is check PP3V42_G3 hot. What do we do here when the charger's not working? If we take a look, we have 18 volts and ground and adapter sends. Adapter sends is going to be what allows the machine to tell that a charger is attached, and it's going to also talk to the charger and tell the charger, hey, you can turn on now, I'm attached. Thank you, Paul Daniels. Adapter sends is going to be where the SMC speaks to the charger and says, hi, I'm a MacBook, you can turn on now, I'm a MacBook, I want my 18 volts. So it's going to speak to it over here, and as you can see, there's a chip. It says X'd on one side and INT on the other side. Now where it says INT on the other side, this is going to be where the signal goes to the computer on sys1 wire. And if we take a look, we look for sys1 wire. That goes to a chip called the SMC. That goes to a chip called the SMC. Right here. So the system management controller is going to be what speaks to the charger, but it goes through a chip over here first. And in order for that chip that it goes through to work, it needs to be getting power. Now, if we check out that chip over here, this chip that it needs to go through is powered on its VCC pin. And the power from there comes from this chip, a logic gate, which will send 3.42 volts over here if SMC BCACOK is present, but this logic gate gets its power from PP3V42_G3 hot. So let's see if PP3V42_G3 hot is present on this MacBook. Thank you, Sonia, for agreeing with my method of anger management. So it says that PP3V42 on this board can be found, I believe, somewhere around here. There we go. PP3V42_G3 hot. So let's see what we get. We're going to turn on Paul Daniels' lovely happy multimeter software, which Paul Daniels was so gracious as to donate to the stream. And we are going to see what we get. And we get 1.14 volts. 1.14 volts is not what we're expecting. We need 3.42 volts. So the first thing we're going to do, as per that instruction manual that I linked to down below, a guide on board repair, the first thing that we're going to do is see if we have a short circuit to ground. There's many reasons a power rail cannot be present, and I go over them in that document, and one of them is a short circuit. So let's see if a short circuit to ground is what we have. I've changed the multimeter over here to resistance mode. One probe on ground, the other on output. We have 2.8 ohms to ground. 2.8 ohms to ground means that the power is going straight to ground rather than going to where it's supposed to be going to. So we are going to see what it is that's getting hot using what we like to call here the Please Bro camera. So here we have the Please Bro camera. Anyway, so we're going to go to display capture over here. Put the chats on the side so I can see what's relevant. And let's see what's getting hot. Now, the Please Bro camera has what's called the Please Bro button. One sec, let me just copy over my power supply transform so that this all looks proper. Now, as you can see, the ISL is getting warm, but up here, the PP3V42 circuit is also getting very warm. Yeah, right there. That's hot. That's PP Bus G3 hot. So let's see. Is it this? Seems like it. Looks like we may have a bad PP3V42 regulator chip. So let's go back to the schematic in the board view and see what that thing is. If we go back to the schematic in the board view, and then we go right over here, you'll see that that chip that we're having problems with looks like the PP3V42 regulator itself. This chip is a very simple job. What this chip does is it takes the charger voltage, which is going to be PP18V5, or battery voltage, PP Bus G3 hot, 12.5 volts or 18.5 volts, and it turns it to 3.42 volts on output. Now this chip is 15 degrees hotter than the rest of the board, which tells me that perhaps it has failed, and it is most likely what is causing my short circuit to ground. So I'm going to disconnect the Please Bro machine. I'm going to say thank you, Please Bro machine, because the Please Bro machine helped me please bro. Rather than have to use my brain to solve that problem, I was able to use the Please Bro machine to solve that problem. So now we're going to take that chip and we are going to replace it with another one. You know, it doesn't look bad. If you take a look over here, that doesn't look like a messed up chip at all, but it is most likely what is causing my problem. Now, do you guys understand why it is that I went for the PP3V42 rail first? Because I saw that there was no green light, and green light requires PP3V42. So I put a small amount of flux there. Did you get parcel from Amazon? I have a bunch of parcels from Amazon at my apartment that I have to bring upstairs. I got a cat litter box, a bunch of cat food. I have to open and check all the little things because usually weekly for the AMAs I'll thank everybody who sent something. And also at work I have greenies. If any of those are you, thank you so much, by the way. Okay, so now I've removed the chip. Now the first thing I want to do is see if that was actually the cause of my problem all along, since it was getting warm. I just want to confirm before I replace it. So I'm going to measure to see if I have a short to ground on PP3V42. And I actually still do have a short to ground on PP3V42. So the regulator was getting hot because it was pumping too much voltage into it, but that was not my actual problem all along. So I did something stupid. I went after the thing that was getting hot rather than going after what was actually causing it to get hot. That was dumb, and that's something that I usually know better at, but, you know, it's been a while. So I haven't been doing as much of this lately, more business administration type of stuff. So that has been screwing with my skill set and turning me back into an idiot. So what I need to do here is I need to not be lazy and actually inject 3.4 volts into the system and see what actually gets hot and go from there. So I'm going to inject 3.4 volts into the system right now and at PP3V42 using my power supply. Let's just change the voltage that the power supply puts out, because sending 18 volts into that power line will make the board very sad. So I put the ground to ground, and now I'm going to put the 3.42 volts directly on the PP3V42. Okay, now we turn the output on, and it's using 1 amp. So whatever is getting warm should be fairly obvious. So I'm going to put the Please Bro camera back on the screen here, so you can all look at the Please Bro camera. Now, as you can see here, the ISL6259 chip is 87 Celsius. Now, before, I thought that the ISL was just getting warm because I had a charger plugged in. This chip was getting warm, and because it was short-circuited. So the PP3v42 chip was getting warm. It was actually getting about warmer than this because it was supplying this with power and it was shorted. Rather than address the actual problem, I addressed the symptom of the problem, and that was dumb. That was a dumb thing for me to do. It's something I usually tell all of you not to do. Figure out the root cause of the problem and address that rather than simply dealing with the symptoms. And I would have figured that out quicker had I actually injected power. I was being lazy. The machine was only taking 70 milliamps. It wasn't putting out enough power to really tell if there was a short. I figured maybe I'll get lucky and something will get hot, and something did get hot. But two things got hot at the same time, and one would have gotten much hotter than the other if I had actually injected voltage, which I didn't do because I was being a lazy ass. And I should probably upload this just so that you understand why it's important to not be a lazy ass and how being a lazy ass can trick you. So we are going to remove my wire. It's no longer needed. We're going to replace the ISL6259 with a better one. If you want to know where to find an ISL6259, you can find them in store.rossfromgroup.com. Okay. So, this is our ISL6259 chip. And also, check this out. Look, there's evidence. Look at that bubbling over there. See this? By the way, if you want to get a microscope, it's a similar quality to mine. You may notice that the image quality on this thing is absolutely amazing compared to a lot of the people who do this. It's because this microscope allows me to get perfect focus on the trinocular port. This can be had at store.rossfromgroup.com. We are selling microscopes. The chip didn't really want to come off of the board, which is actually something that I'm used to when it comes to chips that die. They have a tendency to weld themselves to the board, and I was expecting that to be nastier under it than it actually was. So now I'm going to replace that lead-free solder with some leaded solder. And after that, it's going to make it easier for me to wick that leaded solder off of the board. Solder. Solder. So let's get an ISL6259 put on here, and also a new PP3v42 regulator put on there. This does not work as well as the other tip that I was using. I don't know how Camille was dealing with that. Camille managed to find a way to use hot tweezers tip on the micro soldering pencil, and I don't get it. Also, I'm pretty sure that resistor goes somewhere, but I'm not quite sure to what. That resistor is too small to be on any part of this board here. Okay, now we're going to replace these two chips. These are chips that you can buy on store.rossmangroup.com. Highly suggest you buy them now before the prices go up due to lovely tariffs. We got an ISL 6259 down here. You can see I tinned all those pads. We put a proper amount of flux there. I'm tinning all the little circles around the ISL 6259 because I like little tinned circles. Makes me happy. Don't make fun of me. I like my tinned circles. Someone said, "Thank you for all the effort you put into your videos. I have been a PC tech for 10 years. There's no way I could ever demonstrate what I do live like you can. I hope you consider writing a book sometime in the future. It would be the Sun Tzu of Macbook." Well, a book is not exactly the medium that I would do best at. That's why I do everything in video. But thank you very, very much. I really appreciate that. Thank you. Seriously, thank you. So we are going to take this chip over here. The regulator, that was actually a totally fine chip, and we're going to put it over there onto the other board. These are both chips that can be purchased at store.rossmangroup.com. You should probably get one of them now before we get a 1 or 2 or 300% tariff put on them. The rate that we're going now. What did USPS say, Lewis? Oh, this is the best part of it. So, you know in that USPS video that I did a few days ago where I said that there's this really kind, lovely, amazing postwoman that really puts a lot of hard work and effort in, and she does a perfect job. Remember when I said that, and I was speaking so well of that postwoman, and I said anytime that she takes a day off for vacation, that's when things go to shit and nobody shows up, or the person who shows up doesn't scan stuff? Well, guess what happened? So, at the post office, she came by today, and apparently, I don't know if it's her supervisor, the very dude that didn't pick up any of my packages properly or scan them, and other people are actually blaming her. They're blaming her for the fact that a complaint was filed. The one that actually did their job properly every day. The one that in the video that I cited in my USPS postal complaint did a good job. That's the one that that's the one they're throwing under the bus. So they're doing. It doesn't seem like anything good is getting done there. But I don't. Again, it's the post office. I don't expect anything. My packages have not moved at all. Most of those customers at this point have gotten another one sent. A lot of the people who've complained, we just sent them another one. I don't have time to wait, so and neither did the customers at that. But such is life. So we are going to go back here and go around that ship. Like so. Get rid of all those little excess solder balls that came out. And then plug it in. Plug it in like a Glade. I thought it was really, really, really lame, but they're blaming the person that I actually said did a good job rather than blaming the person that I have on camera doing a bad job. Like, the person that I have on camera not doing their job is the one that's not in trouble. The one that's in trouble is the one that I made 2 to 3 mentions of in that video and said was a great employee. Now, let's see what we get now. So we have replaced the shorted ship with another one, the ISL 6259, responsible for our PP Bus G3 hot. We're going to plug it in. It's not turning on because I still have the power supply set to 3.4 volts rather than 18. So we're going to change that. This is going to be set to 18.5 volts. On. On. Okay, as you can see, we have a green light, but it's only taking 20 milliamps. So PP3V42 has likely been restored. So if I were to measure PP3V42, the first power rail that was missing, I would bet that I've got it. And I do. Now, PP Bus G3 hot over here, this is by the ISL 6259, we're getting 12 volts. That's not what I would normally expect. 12 volts. We're supposed to be getting 12.56. We're only getting 12. Okay, now we got to figure out why that's bouncing back and forth like that. See the amperage? 23, 36, 23, 36, 22, 23, 26. It's going back and forth. So that's strange. So let's take a look around that ISL 6259 area because something funny is going on here. Since it's supposed to be getting 12.56, not that. You know, let's just check some of the current sensing circuit. Current sensing is measuring just fine. Is charger DC in present? $18 volts. PP bus is still 12.08. That's a funny number. Let's see if PP5ES5 is present. PP5ES5 goes to 5 volts, and then 3, 1, 0. 5 volts, 3, 1, 0. Okay, so we've got a short circuit on some other rail, and we got to find it. And what do you know? Check it out. So, I noticed that it was power cycling. What I mean by power cycling is that when we were looking at the amperage the machine was taking, it was going from 23 milliamps to 37, back and forth, back and forth, back and forth. That's why it's very important to have a power supply that I use rather than just using a normal charger. I want to see how much amperage it's taking. I want to see what it's doing. I want to know what it's doing. And just by plugging it in, that doesn't tell me what it's doing. Static voltages don't give me the full story. So now what I did right now is I decided to check another set of power rails in the computer that come next. So let's just bring those up in the schematic and the board view over here using Paul Daniels' lovely, beautiful, amazing software. So if we go down here, there's going to be a list of different power rails. Check this out. So it says always present rails. So I checked PP Bus G3 hot, that was present. Then I decided to start checking the S5 rails. S5 rails are the machines that are going to be on when the machine is off. So PP5ES5 was jumping up and down. So then I decided, let me check PP5ES3, and PP5ES3, that's going to be a rail that's supposed to be present while the machine is hibernating. Just to give you an idea, G3 hot, always on. S5, those are going to be the rails that are supposed to be on when the machine's off. S3, S4, the rails that are on when it's hibernating. S3, the rails on when it's sleeping. SO, the rails that are on when the machine is actually on and being used. So for instance, S3, the machine is sleeping. The RAM gets power, but the screen doesn't. So RAM would be an S3 rail. SO, that is a rail that's on when the computer's in use. CPU vCore or LCD backlight, those are SO rails. Now I checked the S3 rail over here, and that first S3 rail, I just happened to get lucky, it's shorted to ground. 0 ohms to ground on PP5ES3, which is what I was checking on pin 2 of that chip over there. I just happen to know that it's there because I've checked it a million times already. So let's take a look and see if there's a hardy point on the board where I can inject 5 volts in there. So this board didn't just have one short. This board likely has multiple shorts, and we are going to attack and make humble every single last one of those short circuits. So let's see where I can solder a wire to inject 5 volts into the board, and then we're going to go up slowly from there. It looks like on this capacitor over here I can do that, right over there. So on this capacitor over here, we are going to inject 5, well, we can inject up to 5 volts, but I want to start with 1 and see what gets warm. So let me go back to my power supply software and lower that to 1 volt. Yeah, we do have the cursor offset. I probably broke something by being a moron, Paul. You can code this software as well as you like. You're never going to be able to stop me from being an idiot or a fool. So you should stop trying. Many have tried before you and failed. Alright, so let's just... What the... Oh, thing's on. Let me just turn you off for the time being. Alright, we're going to turn this on. Wow, it actually lowers itself to 0.71 volts and takes the full 5 amps. So at 0.7 volts, we're taking a straight up 5 amps right here. It's almost as if I just connected this directly to ground itself. That's insanity. Sean Hannity. So let's take the Please Bro camera and see what the heck it is that could be taking all of this power on this board. So we're going to turn on the Please Bro camera. The Please Bro camera is what's going to tell us when something's getting warm. And let's see what it is that is taking 5 amps at 0.66 volts. So it looks like this transistor here is getting a bit warm. But let's see what's looking like on the other side of the board. Yeah, so this area on the other side of the board is just blank. So the only thing I've really got to go on here is this transistor. So let's see what that transistor over there is for, shall we? Now if I open up the schematic in the board view, Q7520. Well, what do you know? That's the transistor responsible for creating this power line. Imagine that. Look, this here is our U75. This is our TPS 51980. This is responsible for creating PP5ES3, and the transistor that's going to be doing the switching and the pulsing is broken. So the way this works, the way that we're going to get from 12 volts to 5 volts with the switching power supply is simple. So if I want to get your 12 volts of the battery over to 5 volts, the way I do that is by sending pulses of 5 volts through. I mean, pulses of 12 volts through. So here I'm going to send 12 volts, then 0. Then 12 volts, then 0. Now since this is less than half, that means that I'm going to want to send this much 12 volts, this much 0. This much 12 volts, this much 0. This much 12 volts, this much 0. So I'm sending pulses, and what's going to happen over here is that this chip is going to control, let me just make this full screen to make it easier for all of you who are watching there at home. This chip is going to control this transistor. This transistor, it's got this over here, PPVin S5 HS, whatever the hell over there. That's PPBus G3 hot. That is going to be the 12.6 volt rail. 12.6 volts goes into the transistor. The chip tells the transistor open. Bam! It sends 12 volts through the coil to PP5ES3, and then it closes and then sends 0 volts through. Then it opens and sends 12 volts through, and then it closes and sends 0 volts through. Now, what that coil is going to do is it's not going to allow it to switch very quickly. The coil is going to make things slower. It's not going to send 12, 0, 12, 0. It's just going to wind up, instead of doing 12, 0, 12, 0, 12, 0, it's going to go 5, 5. So before the coil, you've got 12, 0, 12, 0, 12, 0, 12, 0. And after the coil, you've got 5, 5. It's going to get averaged out through that section over here where you've got a coil going to the output and then a bunch of capacitors to ground. That's going to be used for smoothing and also storing some power. So that transistor is shorted to ground. So now let's take a look at what it looks like under the microscope, because it may be telling as to what's going on here. I'm also going to stop sending 5 volts to this machine because that's torturing the poor little thing. My power supply is screaming in pain right now. And that is the transistor. That is our transistor over there. Okay, now we're going to take a transistor off of a donor and put it on this. This is my donor to the right. Notice that this transistor never left my hand. Now, I always have the board that I'm working on under the microscope and the board that I'm not working on away from it. Because the board that I am stealing the part from, I don't really care if I knock something off right next to it. That's not what matters to me. What matters to me is not losing my component, not losing my place. So something that I notice with a lot of newbies is that what they do is they'll have the board that they're stealing the component from in the microscope, and then they'll take it off, and then they'll go, oh crap, whoa, how am I supposed to get this back onto the new board? So they put it down, and then they take the new board and they put it under the microscope, and by then the little component that they put down, it's just gone, just poof, vanished. It's bye-bye. And that's not a good thing. So I usually have the board that I'm stealing a component from next to it. Now we're going to turn the power supply back to 18 volts. We're going to plug it in. See what this thing can do. Now, as you can see, it's taking 640 milliamps, and the fan is spinning. The fan is spinning because the power rails now work, and the machine is fixed. So as I have, so this is interesting. So I had a short circuit on PP3V42. That chip was getting hot when in reality the ISL6259 had died. And the ISL6259, after fixing that and PP-G3 hot being restored and PP3V42 being restored, we then had a second short circuit on PP5ES3. And the way we were able to tell that there was an issue there was I saw power cycling. When I say power cycling, I mean that my power supply was saying that the board was taking 23 milliamps, then 37. And it was going back and forth in a steady fashion. 23, 37, 23, 37, 23, 37. So I decided to start checking out the other rails. PP5ES5 was going back and forth, back and forth, back and forth. Now, what a newbie would have done at that point, they would have started trying to troubleshoot PP5ES5, which is not what you do. PP5ES5 was jumping up and down because of another rail. So one of the things to recognize here is that the chip that creates PP5ES5 right over here, U7501, which is available on store.rossmangroup.com. This chip over here is not just responsible for PP5ES5. It's also responsible for PP3V3S5 and PP5ES3. Now, this one chip is providing 3 different rails. So let me try to make an analogy here. So if I'm at the gym and I am lifting weights, let's say I'm doing bench press and the person right next to me is doing squats and he hurts himself. If he hurts himself doing squats, that doesn't stop me from being able to do my bench press. However, if I'm doing bench press and somebody takes a knife and stabs me in the quadricep, even though the quadricep is not the set of muscles used for bench press, the bar is going to fall on me because you just stabbed me in my quad. The same thing is true here, whereby even though PP5ES5 is a totally separate rail from PP5ES3, PP5ES3 is not created from PP5ES5. These rails have nothing to do with one another in terms of sharing a specific power line. They both are made by the same chip. So since they're both made by the same chip, I'm not necessarily going to see, oh, is this cap shorted to ground? Is there a short here? I'm not going to replace the TPS 51980. Anything that hurts this chip is going to hurt any of the rails it creates. So if there's a little transistor that's hurting my TPS 51980, this chip is going to go, ow, short to ground, turn off, turn off, turn off. Now, if this transistor is shorted and trying to take 5 amps out of this thing, it's going to go, turn off, turn off. Now, this chip, unfortunately, it's kind of dumb. You know, this chip cost a few dollars. It's not a fucking genius by any stretch of the imagination. So it's kind of dumb. So it's not only going to turn off this rail over here that's shorted, it's also going to turn off this rail over here that's not shorted. So PP5ES5 jumping up and down was actually a red herring for the fact that PP5ES3 was the rail that had been stabbed in the quadricep. And the chip dropped the bar on itself because somebody stabbed it in its PP5ES3. Now, after fixing that, the board now functions. The fan spins. And if the fan spins, let's face it, the rest of the board probably works. No need to do any other testing there. I'm pretty sure it's ready to go right back to the customer. I'm kind of kidding. But anyway, that's it for today. And as always, I hope you learned something. And again, I'm going to try and put as much effort as I can into doing these videos every single day. I want to have a new upload for you every single day. We're going to do our best to make that happen. I want this to be a consistently educational channel. I got a note from somebody recently, and I got an email from somebody that actually said that they were on welfare, and they are now working at a repair company doing this very work here because they were watching the videos and they learned something. And stories like that are the type, like getting that type of feedback or seeing pictures of the repair shop that people start. That's the type of stuff that actually motivates me, even if I'm really tired and I have a lot of work to do, to come back here and do as much as I can to teach to teach what it is I'm doing, and to also walk you through every step so that it's easy to understand. Like again, emails like that, like I could get 1,000 bad comments a day, and like just one person that sends something like that is the stuff that makes all of this worth it. And I'm going to really try to keep paying it forward and releasing stuff like this that's educational, because it's just there's no feeling like getting emails like that. So that's it for today, and as always, I hope you learned something. Ah! Excellent at data recovery, not the best cameraman. What happened, Steve?
Dude, you lost your MacBook box right on my fucking stomach. Oh.
What do you think is gonna happen if you're standing there? Good to meet
But you didn't run through it. You went through and pushed through it. Jeez.